We click, stream, and share billions of times a day, and we just kind of expect the internet to work. But what if it didn't? Behind every single seamless connection, there's a set of invisible rules, a sort of hidden architecture that keeps the entire digital world from collapsing. So today, we're going to pull back the curtain on 4 of the most essential ones.
No, really, it's a serious question. I mean, think about it. You've got billions of people streaming, gaming, and working all at the same time. Trillions of bits of data are just flying across the globe every single second. So what is it that keeps this, beautiful but chaotic system from just grinding to a halt? Well, the answer is surprisingly elegant. Probably the best way to picture it is as a vast digital highway. And just like our real roads, it needs rules and infrastructure to manage all that traffic. We're talking everything from traffic cops and express lanes to even self-destruct mechanisms for rogue data. Let's kick things off with the most basic problem on any highway: distance. All right, first up is a problem that's basically as old as travel itself: distance. On the internet, distance equals time, and let's be honest, nobody likes to wait. So let's say you're in Brazil and you're trying to watch a video that's stored on a server way over in Tokyo. That data has to physically travel across oceans and continents just to get to you. That whole journey takes time, and for us, that feels like that super frustrating lag or that spinning buffering wheel. So how in the world do you get around the speed of light? Well, the solution is actually brilliantly simple. You just don't move the data all that way. Instead, we use what's called a content delivery network, or CDN. And what this is a whole network of servers spread all over the globe that store copies or a cache of popular stuff. Okay, so when you click play on that video, your request doesn't go all the way to Tokyo. Nope, it gets routed to a CDN server that might be just a few miles away in your own city. That local server already has a copy of the video just waiting for you, and it delivers it almost instantly. It's basically like having a local Amazon warehouse for your data instead of waiting for a package from overseas. And get this, if you're watching this video on YouTube, yep, you're using a CDN right now. It's this incredible invisible tech that makes a global network feel like it's right in your neighborhood. It's the reason Netflix streams so smoothly.
Okay, so CDNs make the internet feel super fast. But that digital highway, it's a very, very public space. Speed is great, but it's pretty useless if your personal information gets stolen along the way. And that brings us to the problem of security.
Whenever you connect to the internet, especially on public Wi-Fi at a coffee shop or the airport, your data is essentially traveling out in the open. It's like sending a postcard instead of a sealed letter. Anyone on that network could potentially intercept it and read it.
And that is exactly where the virtual private network, or VPN, comes in. A VPN creates a secure, encrypted tunnel just for your data. Think of it like your own personal armored car on that public digital highway. All your data gets packed inside this tunnel, and even if somebody manages to peek inside, all they're going to see is just a bunch of scrambled, unreadable code.
You can really see the difference here. Without a VPN, your connection is just wide open. It's like shouting your bank password across a crowded room. But with a VPN, you've created this private tunnel. And even if someone intercepts the data, it's completely scrambled. It basically turns that shout into an unbreakable whisper.
All right, so now our data is moving fast, and it's secure inside its little armored car. But what happens when millions of these cars all hit the highway at the exact same time? Well, you get a traffic jam. And just like in real life, not all traffic is equally important. This is the priority problem. Just think about all the stuff you do online. That video call with your boss, it's super time sensitive. Any delay and it becomes totally unusable. But that huge file you've got downloading in the background, that can take a little longer. Now, if the network treats both of those things as equally important, your video call is going to start stuttering because of that less important download. So the solution for this is something called quality of service, or QoS. You can also hear it called traffic shaping. You can think of it as a traffic cop for your internet connection. A network administrator can set up QoS to give certain applications, like that important video call, priority access to your bandwidth. So as you can see, QoS is really all about creating an express lane for your data. Your live video call, which needs that data right this second, gets top priority. Your big file download in the background, it gets told to wait in the slow lane. That download will still get done, don't worry, but it's just not allowed to mess up your more important traffic.
And that brings us to our final function, which solves a really strange but also really dangerous problem. What happens when technology gets stuck in a loop?
Look, computers are great at repetition, but sometimes that can backfire. Big time. A simple little misconfiguration can trap a packet of data in an infinite loop, just bouncing between two routers forever. Now imagine that happening with thousands of packets at once. You get a massive digital traffic storm that can bring down the entire network.
So to stop this digital nightmare from happening, there's a brilliantly simple solution called time to live, or TTL. Think of it like a self-destruct switch that's built into every single piece of data that travels the internet. And it's not really a timer in the way we think, like in seconds. It's more of a simple countdown.
So here's how it works. A packet of data starts its journey with a TTL value. Every time it passes through a router, which we call a hop, that router just subtracts 1 from the count. Now, if a packet gets caught in one of those loops, its TTL value is going to drop really fast with each bounce. And as soon as that TTL hits 0, the very next router that gets it just throws it away. The loop is broken, and a network meltdown is avoided. And you know, these aren't just some abstract numbers. Your own computer actually sets a default TTL value for all the data it sends out. Windows systems usually start packets with a countdown of 128, while macOS and Linux use 64. And since most places on the internet are only about, say, 15 hops away, this gives you a huge safety margin. But here's the fun fact. The term time to live actually has a second job. When we're talking about routing data packets, TTL counts down in hops. But for the Internet's address book, the DNS system, TTL is a literal timer, this time measured in seconds, that tells your computer how long it should remember a website's location.
So, for example, a DNS record might have a TTL of 300 seconds. That means your computer will remember that website's address for exactly 5 minutes, and then it just deletes it. It's just another clever time-based rule that keeps the Internet's address book accurate and totally up to date. So there you have it, 4 really essential tools in the Internet's invisible toolkit. We've got CDNs for speed, VPNs for security, quality of service for priority, and that TTL self-destruct switch for safety. Just 4 really elegant solutions to 4 potentially huge problems. And the crazy thing is, these are just 4 of the hundreds of invisible rules that make our digital world even possible. It's this hidden architecture of just brilliant ideas, all working together perfectly. It really makes you wonder, what other unseen systems are out there, quietly shaping every single click, every stream, and every connection you make?